Okay, let me share the screen with you. Idora, any questions from the two of you?
No.
Okay.
This only got this one.
Yeah. Okay. Let's take a look. Oh, yes, Winona, Fedora, you're done with the homework that was assigned to you. Thinking yours all done, huh?
Yeah.
No.
No, that sounds like Fedora. How about Winona?
那觉得是Winona.
Oh, okay.
No, we're just not done with everything. Like we
So
did,
not
but we're
done.
not done with everything.
Oh, okay. Okay, so Winking, you're still the best student. But come guys, anyway, I want you to look at your homework again, Winking, you too. Go on your homework because I want to go through a few very strange reactions that you probably didn't notice.
And
Yeah, okay, if you notice that, I really must commend you. Okay, come. I'm showing on the screen right now for the two of you at home, and for those who are here as well.
still not coming out.
I don't know, no idea. Okay, come. Look at the screen. This is from your homework. Especially those that I marked up with watch up. So let me just erase the whole stuff first. Watch out is here. Watch out is here and here. Let me lock them up first. Huh? Okay, come. Look at this one.
Oh no.
I think here. Do this.
No.
No. Okay, come, Ming. What are you supposed to get for this?
PB plus 2 HCl plus PbCl2 plus H2.
Good.
I think one PBF. You know which 2 plus or plus it is?
No, that is not the main problem. Okay, come, girls at home as well. Well, thinking is correct. Let me see if I miss out anything. No, huh? Yeah, correct. Now, write the states as well. Okay, good. HCl thinking.
Curious.
PbCl2.
PbCl2. Aqueous.
Okay, guys, as
Sorry.
those girls at home as well, let me point out a common mistake.
Hydrogen can be solid. Wow.
No, she's not referring to hydrogen. I highlight lead chloride. Make sure you put it as solid.
Oh, no.
A lot of people have made the mistake in the past, lots and lots and lots, but hopefully none of you from this class, because I will highlight it all the time. But that is not all, because especially for the pure people, your story can go more than that. Now, let me just draw it up. Imagine you have your beaker, you add in your HCl, and you put in your lead accuser. Okay? Let me just do it. Now, what happens is, yes, Minona, you take note as well. Now, what happens is, where is your lead chloride formed? It will form on the surface of your lead solid. Okay, so you will have a layer of lead chloride. And guess what? I have already emphasized it is insoluble. And guess what happens next? Nothing. That layer prevents further reaction. This has come up before. I mean, not all the time, but definitely they will tell you, put a piece of lead into acid. Bubbles are formed, but it stops after a while. Why? This is the reason. And so make sure nobody gets careless if the same question comes up. And so I repeat, normally the question will say some bubbles will appear, but they stop appearing after a very short while, and they ask you why. This is the reason. Okay, all got it? But of course, you can always come back to this mirror board to copy down if I didn't erase it.
You might just write up everything, then I just open mirror.
Oh, no, that's not going to be beneficial to you.
What do you mean?
You need to do it.
I will remember.
Okay, so let me go on. Now, how about this? I hope you notice this one has the same problem. All right, likewise, lead and sulfuric acid. Make sure your symbols are all correct. Thinking you've done the lead and sulfuric acid as well.
Yeah.
Check your stick symbols. Yeah, Jing, are you writing down?
Yeah, checking.
Yeah, so they got except for
Except for lead sulfate,
it's
barium sulfate. So, take note, everyone, girls at home as well. Lead sulfate is solid. Oh, and of course, in case you didn't notice, the same thing happens.
wastage something. Wastage means
The same thing happens if you add lead to sulfuric acid. Oh, that also means you better be familiar with solubility rules. But of course, in this case, it's lead sulfate rather than lead chloride. Okay, I will not be writing everything down, but I hope you all get the idea. Now, the other one is, of course, calcium. Right. Now, likewise, Yingting, I hope you
Changed.
yeah, change your state symbols. So likewise for calcium. Hey, Jing, you haven't done any
No,
that's bad.
completely forgot.
Okay, so likewise, state symbols are similar to that for lead. Now, of course, not surprisingly, you get the same problem. Okay, you can take note as well. So calcium sulfate is also an insoluble salt, not so it prevents further reaction and blah blah blah. Because it forms a layer on the surface of calcium. And so look out for this. They like to ask this, especially for the pure people, but occasionally it comes up for other people too.
They could combine
Shit.
my life to be easier.
Okay.
Just.
Well, you can change your mind next year.
And I want drop in man. I cannot really.
Really?
No.
You can choose whether you can take.
Huh?
I thought it's a must take one.
Yeah, I don't.
No,
Sure.
can still not. But your parent need to approve,
Agree.
need to sign.
You definitely said no.
Oh, and by the way, you better count you have enough subjects. You don't drop until you know what subjects in your L1, R4.
I really want to drop chemistry.
Huh?
I really want to drop chemistry.
You can't drop chemistry.
Yeah, I really want to.
Chem is okay except for no. I cannot with no.
Not really.
What? I want tear the bullshit.
I cannot with acid and bases.
Yeah. Okay, come guys. Same thing for this. Just be a bit careful. You have the same culprits again. This is the second page, acid plus metal carbonate. All right, so again, watch out. So if I write this down, calcium carbonate plus sulfuric acid.
Yes, they got.
Yeah, it's somewhere next to the printer. With calcium sulfate again. And you get H2O plus CO2.
Oh, this which I didn't write. The symbol.
Oh, okay.
Oh my god.
Never mind. You can go and do and come back next week. Now, guys, I need you to write state symbols. Calcium carbonate, Minking?
Calcium carbonate. Sorry.
Yes.
Oh my god.
Acid is always aqueous by default. Calcium sulfate, you should know by now. Okay, so again, look out for this. The same thing may happen again. I don't think I need to write out again, but basically the reaction may stop after a while because this insoluble salt will form on your, in this case, calcium carbonate. All right, so look out for this, especially if your question tells you, it produces effervescence for a short while and then stops suddenly. Think about this. This has come up many, many times. Okay, I'm not going to write for lead, guys. Same thing. Watch out for lead chloride and watch out for lead sulfate. You will have the same problem. Lead chloride and lead sulfate are both insoluble. But lead nitrate, no. Lead nitrate is soluble, so it's not a problem. Yes, all nitrates are soluble, so make sure you have your. I mean, serious lah. I think I emphasize this more than enough. Make sure you're familiar with your solubility rules.
Chloride, sulfate, nitrate, and hydrogen oxide only.
And
Or
what-
still one more.
Yeah. Guys, my set of solubility rules have 6 rules. 6. Even though your school may have a different set of rules, slightly different. 6 rules. What are the 6? Okay, yeah.
Only, yeah, I do those company one.
Okay, so in my rules, I base them on the anions. Chloride, sulfates, nitrates, carbonates, oxides, and hydroxides. I mean, personally, I think it's easier to remember. And reminder, the first 4 are considered salts. Chloride, sulfate, nitrates, carbonates, whereas oxides and hydroxides are considered bases. So yeah, try to use the right terms.
PCl is solid.
Case.
Oh, no. Sorry. Okay.
Okay, any questions, Fedora, Winona?
No, don't have.
All right, great. Today can't see Winona. Don't tell me your webcam is spoiled.
Yeah, my camera spotted it. I'm not sure why.
Oh, okay. That's unfortunate. Try to get it fixed.
Okay.
Okay, let's go back. Let me see anything else to highlight to you. Just okay, same thing, third page. Now for third page, I want you to watch out for one of them only. This one here. Calcium hydroxide and sulfuric acid. Watch out for it. You probably know the reason by now. All right, because in this case, calcium sulfate is formed. And of course, it leads to the problem we mentioned earlier.
Okay.
So when you want to fill in these few pages, make sure you take all this into account.
You can show the first page again.
Show the first page.
Oh, like show the first page again.
Okay. I mean, I didn't write much, just like that.
Okay, can.
Yeah, Xinjie, I don't know whether you were here in time, but basically I asked them to watch out for this tree. 1, 2, 3. Because they produce insoluble compounds.
Oh, page 2.
Hmm?
Page 2.
H2. So why is H2 a problem?
I want to see again.
Oh, page 2. Oh, okay. Come. Yeah, page 2 is here.
Only PB and calcium sulfate solid, right?
Oh, one more time?
Only these 3 that you highlight are solid, right?
Yeah.
Okay.
I mean, there are of course others, but they are not in this table. So yeah, it's so a mistake I wrote last week.
Solid. Okay.
Yeah. Go to the last page. Now, last page, I want you to watch out for 2 of them. I highlighted here. And you probably can deduce the reason, but I read it out anyway. And same thing in this case, this is fine. Okay, but hold on first, don't just keep all your homework, because there's a slight difference in the form page. Let me double check. Okay, look at your fourth page. There is a slight difference here. For this two that I asked you to watch out for. Now, try writing the full fraction. The full equation for this and this. Try writing out, here. Ammonium carbonate, ammonium sulfate. But for those who have trouble, I'll write it out myself as well.
It's insoluble.
Calcium carbonate is insoluble.
So it's soluble.
Yes. Add state symbols to your equation, of course, as I always insist. Ammonium carbonate,
What?
state symbol.
Oh, AQ.
Good. It's a star salt, by the way. So AQ. Calcium hydroxide is a bit ambiguous, but let's put it as AQ, which is your lime water you find in your lab. But calcium carbonate is solid. Ammonia,
Oh, I guess.
Yes. Okay, fine. You can put it as a gas. If you put it as AQ, you're not wrong either.
You got say.
Yeah, I did. Now, guys, look at this equation. Do you think you are going to have a problem of the reaction stopping? Look at your reactants. Do you have any solid? No solid, so therefore you won't have a problem of a layer forming. So this is slightly different because you have no solid reactants. In other words, the reaction will not stop suddenly. It will continue.
Because there's nothing to wrap around.
Yes, correct. So, these are all the small things you have to be careful of. Which also means, what will you observe? You will observe a precipitate. Okay, maybe I can draw this. This will form a precipitate. White color, by the way. Yeah, because your original reactants are all equals. You can't see anything, all colorless. But this guy is a solid. It's going to be very obvious. That's your observations. Let me just write down observations. Okay. The second important one. Jing, will you see effervescence?
No.
Fine.
Ammonia.
Okay, what about ammonia?
Water.
Water. Okay, you see, I know you know the answer. Okay, everyone. Despite writing ammonia as a gas, there is no effervescence. Very hard to get effervescence from ammonia. Very hard. It's not H2, it's not O2, it's not CO2. Because even though we wrote it as a gas, it dissolves readily in water. You won't see bubbles. Instead, come add in. Instead, it will give you a smell. The smell can still come out too. Now, Ming, what's the modern answer to describe the smell?
Sure.
Yeah. Yep, those at home take note. This is the model answer, tangent smell. Yeah, P, but P is not the model answer.
Oh, yeah, hot tea.
Okay, so look out for this one. Look out really. Okay, likewise, look out for this one as well. This one. For calcium sulfate, it's the same thing. Yeah, a lot of things. Alright, you will for calcium or for this box here, you will have a similar observation. Alright, because calcium sulfate is white and it's also insoluble. Any questions? I hope this didn't scare you off. Just one last thing. Let me go to the third page again. Again, can you write out the equation for this, the one that I highlighted? So if you write it correctly, okay, of course I get my salt and water, because this is neutralization. Add in the state symbols. Calcium sulfate, I think I mentioned it a few times today. It's rather insoluble, so put it as solid. Now, reminder, the reaction will not stop suddenly. Well, reason because there's no solid reference. For a layer to form. Okay, so instead, you have the same observation. You have your precipitate. Yeah, if you keep on until all the reactants are used up, or at least the limiting reactant is used. You have a white PPT, but please take note there's no smell here because there's no ammonia. So don't just keep on writing pungent smell all the time. Okay, there's no smell. You only see a white PPT. Yeah, so quite a few things to take note of, just out of these simple reactions. Okay, okay. Yeah, for you, no problem.
But,
Oops, let me charge my laptop.
you still go, I mean, you can still buy a bus with like $1.60 in your card.
Yeah, I think so. Unless it's less than $1.
Yeah.
Okay, yep. Any questions from anyone? Well, if not, I still expect this homework to be submitted.
No way lah, I'm not done already.
Next week, 6th.
Okay, next week, yeah. All right.
Yeah, 6th.
Okay, yep. Those at home, if you have any questions, just voice out. Okay, let's go on. I intend to do some quick revision. Okay, how come Francis?
If I see.
Okay, come. Come, Winona, tell me what kind of bonding do you know of?
You call me?
Yeah, okay, Fedora, since you answer.
Call you
Fedora,
lah, stupid.
what kind of bonds do you know?
Faster!
Ionic and covalent.
Ionic and covalent.
Okay,
And metallic.
anything else?
Metallic.
Metallic, good. Anything else?
Not sure. Sorry, Carol, just now we were shouting at our brother.
Oh, we still have a brother.
Yeah, younger than us.
Oh, that's tough. All right, so ionic bonding, covalent. Just now, Fedora mentioned metallic. But this one is not for Winona. Do you think anything else? Think anything else?
What?
Any other kinds of bonds?
No.
No.
Oh, wait, the giant. All those is it?
Well, that's not the bond. That is more about the structure.
Oh, then what? Still got one.
Okay, come everyone. Winona included. There's something called iMatter. Something was
Intermolecular forces of attraction.
Okay, thank you. Okay, very simple ionic bond between metals and non-metals. That is why you better know your staircase well. Make sure you know what is a metal and which element is a non-metal. What else? Ionic bond involves transfer of electrons. Coming from where to where?
This is the positive. Positive, negative.
Okay, let me rephrase your answer. Transfer electrons from metal to non-metal. They haven't become positive or negative. Ionic bond generally considered strong. Okay, and therefore hard to break. Okay, then well, you can write the same for covalent bonding as well. Is it strong? Is it weak? Does it involve transfer of electrons? Is it between metal and non-metal, or is it something else? Yeah. You think covalent bonding strong, weak, intermediate?
Good at ionic bond.
Okay, come. The official answer is considered strong as well. Covalent. What can you talk about covalent in terms of electrons?
They share.
Yes, that is the key word. Make sure you use the word share or transfer. Okay, covalent is between what and what, Jingjian?
Between non-metals
Good.
and non-metals.
Yes. between non-metals. Let's reserve the last two for the two girls at home. Fedora, metallic bonding. What can you
Yes.
say about metallic?
Metallic bonding is positive ions are bonded and then in a sea of delocalized free moving electrons.
Ah, okay, good. Oh, model answer. Metallic bonding is only for pure people.
Then she take
Yeah, she does.
oh.
Oh, and by the way, obviously it's only within metals. But it can include alloys too. Or at least certain alloys. Well, of course, it's pretty strong in transition metals. But that's not the full story. It can be weaker, especially in group 1 metals.
The last two parts. That one is different chapter.
Yep, different chapter.
Oh, that means no. For now.
Okay, lastly, IMF applies to everyone. Right, you know now, you do. Now, you know now, where do you find IMF?
Between covalent bonds.
I wouldn't say that's entirely correct, but it's between molecules perhaps. Let's use the word molecules.
What's alloys again? Alloys.
But what's alloy?
Sorry.
Can I go back to it later? Let me finish with this first. Now we know now, IMF, is it considered strong or weak? Yeah, you know now. Strong or weak?
Just the question again.
IMF is considered strong or weak?
Weak.
Good. Everyone
Weak.
also knows that. Good. Okay, you better take note since you haven't, I'm very sure you haven't come across IMF. Better take note. Is great,
sorry.
which also means that will lead to low melting point and boiling point.
Yes. That's fine.
Graphite is not low. Okay, so yeah, those are the basics. And by the way, this is only for bonding. Because together with bonding, they'll ask you a closely related question. They'll ask you about the structure. Okay, let me put a star here. This is only for pure. Okay, structure, very simple. If it's ionic bonding, you think what kind of structure?
Giant lattice structure.
Good, giant lattice structure. But to help the pure people differentiate, I'll call it giant ionic structure, even though it's not wrong to call it giant lattice structure. Automatic, any substance that has ionic bonding is automatically a giant ionic structure. And you have all the associated features. Okay, IMPBP. And also electrical conductivity. Okay, can you remember electrical conductivity?
Yeah.
What's the answer for giant lattice structure?
Oh.
Okay, so can conduct only in molten and aqueous state. Okay, I don't think I need to write down, but it cannot conduct in solid state. Okay, so remember that. How about this? If something has metallic bonding, what kind of structure will you get?
Metal structure.
What's the proper term for that?
Giant metal.
Yep, good. Giant metallic structure. Again, this is obviously only for pure people. Okay, so I put a big asterisk here as well. Okay, melting point, boiling point. Most of the time is high, except for certain metals like group 1 metals. Electrical conductivity. Okay.
And about electricity.
Okay. Solid, liquid can conduct electricity. Okay, so solid and liquid. What's the reason? Xinqian, how come you can conduct?
What? Metallic.
Yeah,
It's metal or
you got to write something, right?
electrons?
Yeah, because of the sea of localized electrons, they are free to move. But more tricky is covalent compounds. What kind of structure do covalent compounds have? Two possibilities. That is the tricky part.
Strong covalent bond with intermolecular.
Repeat my question. Thinking for covalent bonding, you can have two possible structures. What are the names of the two possible structures?
Simple.
Yeah, Xinxian?
Simple and gel.
Good. Simple molecular structure. Or you can quite simple molecule if you want to. Nothing wrong. What's the other one, Xinjie?
Giant.
Okay. Now, if you see covalent bonding, the other possibility is giant covalent structure. So you need to be able to differentiate which one is which. Oh, just a note, giant covalent structure is only for pure people. So I put an asterisk here again. Okay, give me a few examples, things here. Simple molecular structure.
I don't know.
Oh, you encounter them every day.
Oxygen.
Yeah. Oxygen, nitrogen, water, CO2. Your good friend ammonia in the toilet. Yeah, lots of them. Now, how about giant covalent structure? Okay, example. Carbon, yeah. Carbon, yes, but specifically
Black.
black, graphite, and diamond. Yeah, of course, this is just for the pure people. And the other example, everyone better know. I mean, the pure people better know. Besides carbon is silicon.
Let me just understand.
Hmm?
I remember one is sense.
Ah, good. What's the formula for sand?
I don't know. Silicon dioxide.
Yeah, good. You see, you know. I repeat, these are the 4 standard examples. Of course, there are others that may occasionally come up, but you have to know at least this 4. Only 4. Oh, by the way, this is called silicon dioxide, as Jingjie mentioned. There's another name for that. It's also called silica. Yeah. No, just silica. And of course, it is the component of sand. I would say part is actually sand. Main component.
It can make sense.
You can make sand. How?
You combine.
Oh, well, but where are you going to find silicon?
I don't know. How do you find?
It's going to be expensive because it's used to make semiconductors. Oh, so it sells pretty expensively.
Go beach.
Beach, yeah, lah, that's the free one, free sand. No need to make. Correct, so I repeat, these 4 examples are more for the pure people. Okay, last one. Where do you find IMF? Let's ask them. Come, Fedora. What kind of structure is associated with IMF? Disappear. Tell Fedora what kind of structure is linked to IMF? Nothing.
Covalent.
Covalent. Okay, but I'm asking about the structure. So to be exact, IMF is present in simple molecular structure. Okay, so take note. Once you have a simple molecule like all these guys, they definitely have IMF. Oh, we know now this applies to you, so make sure you understand this part. And by the way, let's go a bit further. Now, essentially, they all have low melting and boiling point for simple molecules. And I want to be very clear here. Why?
Bonds can breathe easily.
Mm-hmm.
Then fly. Change state.
Yep. Okay, lah. You see, since you actually understand what's going on. Now, whenever you have change of state, you are only affecting the IMF. You are either forming IMF or you're breaking IMF, which are quite easily broken. But what I want you to remember is when you have a change of state, it does not affect the covalent bond. Make sure you understand this part.
Oh, then what happened?
The covalent bond will just remain.
Oh,
That means, for example,
oh.
like C is still bonded to O. Whether you melt it, boil it, freeze it, condense it, this covalent bonds will still remain. So you're not breaking the covalent bonds.
I have to remember this.
And just to make a very clear, but this is a different story. Look at giant covalent structure. Meeting you have come across all this, MPDP. Oh, you look so tired. Now this is different. Once you have a giant covalent structure, they tend to have high MP and DP because a change of state affect the covalent bonds. That is the big difference. So if you want to boil them or melt them, you are breaking the covalent bonds in a giant covalent structure. And of course, that is very energy intensive.
Sand in would be good.
Wow, that's going to be very high temperature, very high.
Oh,
1,000 definitely, 2,000.
sun.
No lah, you don't need that, but you're talking about 1,000, 2,000, or even 3,000. Oh, just one last point, especially for the pure people. Only for pure people actually.
Wow.
Occasionally it comes out. There's one other place that you can find IMF.
Not the graphite.
Yes, graphite, good. So just keep this tiny tidbit in mind, even though it doesn't come out all the time. Okay. But it doesn't affect melting point and boiling point. Graphite is still very high. Okay, questions, anyone? Let me see. Did I miss out anything? I don't think so. So, okay, I repeat, just to quick summarize. You can bet that your exam or test will involve both bonding and structure in the same question. They always ask about that. So look carefully, make sure you answer both. Mention the structure, mention the bonding if you want to get full marks. Okay. Well, oh yes, lastly, let's answer Minting's question. Now, Minting was asking about alloy. What are alloys? Come, Jingjian, I'm sure you know.
Oh,
Alloys.
I think she know.
She knows.
You mix metal and marble.
Yeah, I think that is the key word there. Okay, alloy is a mixture. It's not a single substance, it's not a pure compound. Mixture of metal and yes, one or more other elements. I think the keyword is mixture. Make sure you highlight that. Is there an example?
Huh?
Alloys.
alloys.
Yeah.
Cannot remember.
Yes, okay. Come, I'll give you a few basic ones. Make sure you remember steel. Steel is a mixture of iron and carbon.
You know that.
Yes. Well, it doesn't come out often, but we are supposed to know that.
No, I mean the formula.
What formula? No formula.
Oh,
The other one is stainless steel.
thing.
Now, alloys are usually for the pure people, but occasionally, alloys can still come out for others. Stainless steel. Now, since steel is inside, of course, you have iron and carbon. But to make it stainless, you add in chromium. Just one last example, brass. Oh, these are all still considered metals. Steel, stainless steel, brass, they are still metals. They can still conduct electricity. So brass is very easy, copper plus zinc. Yep, I give you the most popular examples. Okay, any other further questions? All right, if not, those at home, start working on your worksheet. Those in class, well, you do the same thing.
Oh, I cannot find purely.
King, are you saying bio is easier?
Yes.
Really?
Bio brain dig.
Brain dig.
Memorize.
Shit. But she get remember them though.
Yeah, lah, brain dead lah.
Instead.
Is it not?
Yeah, you just have to remember. Some of the words you don't see any meaning on, but you still have to remember.
Ammonia is non-metal.
Ammonia. What's the formula for ammonia?
NH3.
Chemistry,
Oh yeah.
Then H. Yeah. Everything is non-metal.
That's good. Thanks for research.
So I don't know, because especially for you guys, they come up with some new compound, you need to figure out something you've never seen before.
Not info. B is what?
What V? Group 5. Group 5. No, wait, I can't. Group 15.
And group 3 I.
I don't know.
Alright. 17. Oh. What did you put for 2?
Still doing.
Why meeting?
What did you put for 2?
Number 2. Wow, this one, you have to draw the dot cross diagram for number 2.
CC.
Oh, and what's the answer for C? C.
2.
2.
No. Okay. So,
Yo, what got move? Oh,
okay.
You're not going to run away from most, Jin.
I hate more so much.
How much of 1 more?
No difference lah, huh? You go to NA, there's no have most.
But the more is easy.
What is
What
question?
should I have?
Which one has more?
Third question got more.
Number 3. Oh,
Is it aluminum?
number 3.
If
The formation. Okay. 1 mole of each metal oxide to the metal does not transfer exactly 2 moles of electrons.
wait, it's not. It's
No, it's not.
But
It's wrong. What are you doing?
But
Um, F.
Yeah, not easy. This one is not easy.
Huh?
Number 3 is not easy.
oh,
You have to use something I haven't mentioned before.
okay, no need to.
Oh, but you can come up for your exam.
No need to. This is MCQ. Fuck it lah.
No sharing. But I'll show you the exam. Good.
Right, oppositely charged ions.
Okay. Since Ying Ting asked about question 3, I'll just quickly show it to everyone. Now, for question 3, it'd be good if you can write out something like this first. Of course, make sure the formula is correct. Make sure here is 1, even though I didn't write it out, but make sure this is 1 mole.
No, another one 2 more.
And this is 3, 4, 2 minus. Okay, make sure you can write out something like this. Now, of course, I can do the same for the rest, but I won't do for every single one. Now, my suggestion is write another equation. How do I get, okay, they are more concerned about the metal atoms. Okay, let's look at the metal atoms first. How do I get this aluminum 2 element 3 plus? Basically, I need something like this. I need 2 aluminum. And what happens to them? You have to minus 6 electrons to give you this. Now, likewise, if I do it for sodium, I need to start with 2 sodium or 2 moles of sodium, and I need to minus 2 electrons. So the key is this number. I need to minus 2, whereas for this case, I need to minus 6. Now, if you do the same for the rest, you would notice the same trend. Okay, so let's say magnesium oxide. I think this is even more obvious. Magnesium 2 plus and oxide. So likewise, I just write one more equation here. To get magnesium 2 plus, I simply get magnesium minus 2 electrons or 2 moles of electrons. And I get this. So anyway, you see the trend is still true. And you probably know the answer by now.
Okay. I'm correct.
Yeah, but you were guessing, right?
I cannot remember that. They my 2 same questions, so I did before, so I'm trying to remember. Number 4 is metallic structure. Metallic bond is it?
Number 4. Yep.
2A.
No, not necessarily. It can also be an ionic bond, because ionic bond is attraction between cation and anion, which are opposite as well.
Metallic bond doesn't necessarily have high or low boiling point.
Yep.
Should be that.
But okay, sorry, I missed out one important word. No, it cannot be metallic bond. Just a question for linking about question 4. I missed out this word. It's oppositely charged, not particles. They use the word ions. So metallic bonding is not counted because ions have to include. In this case, they imply cations and anions. It cannot be between cations and electrons because electrons is not counted as an ion. So once they say oppositely charged ions, it implies an ionic bonding. So which of the answer reflects an ionic compound?
Ionic. Yes. Oh, no.
C. That's not a truth.
Oh, so hard. I'm still on first page.
Can't. I was just brain dead now. I was studying just now.
Studying what? Chemistry.
No, history.
Oh,
Useless.
that means no conflict. Your brain won't get affected.
Please, I had to memorize.
They're using different areas.
History so useless.
History, yeah.
Actually, all three humanities useless. Social studies useless.
Social studies is the worst.
Like, useless one. Like, no one gives a shit, bro.
What do I need to know about the presidential election?
Oh, wow.
Look, if they actually ask about that,
Thanks.
then I don't do paper.
Don't do then how? Fail
I rely on my other humanities.
Yeah, I mean, it goes without saying, most useful is still English.
No, Badang.
Mother tongue.
No. You see that? Not everyone here knows Chinese.
Okay, no, actually, math.
Yeah, fine.
No, math.
Maybe. How much do you get to use all the advanced math?
You go supermarket, right? They
Yeah.
use lock and lock.
Yeah, do you use log and log? You all haven't studied differentiation integration yet, right? How often do you use that? Vectors, how often do you use that? Matrices also. You just need primary school math to survive.
So they should just stop,
English.
like stop teaching all that. Like, you see all the trigo stuff, right? I also don't know how you're going to use it, like sine, cos, and tangent.
Unless you study engineering.
Oh no, then maybe I don't want to engineering.
But that one is more for the mechanical and civil engineering, or electrical as well.
But you won't draw the graph, right? It's the computer who will draw the graph, anyways.
Yeah, lah, but when you study, you still have to do it.
The graph, tongue, it is constant.
Yeah, I mean,
That is the
look at your waves. Are they all sine waves, cosine waves? They are, no?
No tension.
actually is useless.
It's actually useless. Yeah,
Oh, it's so weird.
it's the least useful.
What is it there for?
Remember the atoms, oxygen, fluorine, carbon when they are covalent compounds.
We know that. I see that you're in the mirror.
Wow.
Are you able to put your comment or the answers inside the mirror board?
Carbon has 4, right?
Board.
I don't know. I'm just looking at the question.
4 plus,
Oh,
right? Carbon is 4 plus.
4 plus.
Is it?
It is very rare for it to become 4 plus. It tends to become 4 minus.
So is it D?
Which question?
6.
6. Oh, still first stage.
I don't know. Is it impossible?
Count in case you see the word covalent, you see the word share,
Oh,
So-
haha.
they do not become ions.
Okay.
So there goes your 2 marks.
Still one.
But for the pure people, your MCQs, you have 40 MCQs.
Oh, I love life.
Mm.
You love life.
40. 1 minute per question.
I no wonder. 1 minute per question. How to do more question 1 minute? Take a 5 minutes to one.
So they can give all.
Skip first, no? Yeah, sorry.
Oh, nothing.
Then if legit cannot, just the right answer.
Yeah, like if you're desperate, then just throw a die. Four-sided die.
Take eraser, you have one A, B, C, D.
Fluorine.
What about fluorine?
Oh, sorry, I'm looking at the wrong thing. Oh, no wonder. So weird.
What? You're still thinking about ions?
Sorry. My brain is not braining now.
Very noisy. I hate things moving.
Brain is 9, 2, 8, 1.
Hey guys, I don't know whether you hear one trick as well, right? For covalent compounds, only for covalent compounds. The trick is this. Okay, you want to hear?
Yes, I mean,
Now, if it involves carbon, it will have 4 bonds, 4 covalent bonds. If it involves oxygen, 2 bonds. Hydrogen, 1 bond. Nitrogen, 3 bonds. I mean, of course, all these bonds are covalent bonds. Halogens. I assume you know what are halogens. 1 bond. So, oh, by the way, fluorine is halogen. So, example, if you ever see something like this,
Just draw it out.
yeah, I mean, you can just draw it out without using. No, the point is you don't want to draw a dot cross diagram because that is going to waste a lot of time.
Just draw a rough one.
A rough one, okay, also can. But anyway, for this particular case, you just know that carbon has 4 bonds, so draw a C with 4 bonds. Hydrogen has only 1 bond, so you put a H here, and H here. Finally, halogen has 1 bond as well, so the Cl will be here. Okay, so there are 4 covalent bonds in the whole molecule. And I think I told you guys before, 1 covalent bond consists of 2 electrons. To form that bond. Okay, so obviously these 2 electrons are what we call bonding electrons.
Sure, never said that. Sure, never said.
So is it? But this can come up, your question can ask you how many bonding electrons are there.
What the hell? Just draw out and see. Draw in 1 minute. How's it? Actually not 1 minute, 30 seconds.
30 seconds. So for O levels, the 2 electrons is split between each element. Okay, so 1 from each element. Or 1 from each element.
why is that drawing so weird?
Huh? Anything? Question?
No.
Oh no. Okay.
Question 7.
7. I thought you saw the answer.
Oh yeah, I thought I saw B. I remember it was B.
D.
Was it not? Was it not?
Is it D?
D. Come oxygen. What is oxygen? Oxygen, do they exist as what? Molecules, atoms, or what? They always exist as O2.
So then it is
And O2 is a molecule.
yeah.
No, sorry. And freezing is a change of state. So it doesn't affect the covalent bonds, they still remain as molecules.
Hi.
Alright, it's not going to break the molecule, no?
Change of state.
Okay, I mean, we wrote down just now, but no harm writing down, change of state does not affect covalent bonds. So the molecule is still a molecule. But I hope you know the two O's are bonded by covalent bonds. Okay, so make sure answer C.
I pressed the cancel wrongly. Wow.
It's not going to lose electrons, it's not going to become atoms again, it will just remain as a molecule. Then try to get this right. No problem.
No.
Can I assume all you have no problems in dot cross diagram? If you have, better voice out.
The weirdest ones.
Weird. Yeah, this is the weird dot cross diagram.
They just lazy.
Supposed to be.
Yeah, it's supposed to be, but I don't know. I think this year they were lazy. They just put it in this pattern.
All the angmoh all lazy.
Yeah, lor.
Maybe.
They wasted a whole 22.
Answer is C.
Let's see. Yeah, you see. I know that you don't do because you know all the answers.
Maybe I don't do it. I know this is TIS, but that doesn't mean I remember every answer. Like I've never seen this answer. You're probably not very old.
Which of four means that you can come up again?
I hope the teachers they just lose their old copies of the TIS.
Oh, no way. No way.
And they're dog idiots.
But it's their responsibility to keep all the TYS.
My
Who
dog eat my
is they already eat it?
Eat. Who eat it?
The dog.
Teacher? Or the dog?
What if?
No, it won't happen.
It will.
Then the teacher is going to suffer for it, punish for it.
Ah, really? The school punish them.
You're losing. Exam papers, huh?
8
No,
per
big deal.
like 4 positive ions. Wow.
Oh man.
Just like, oh, I tell you one interesting story. Not the dog, but it's quite dramatic as well. In the polytechnic, there was one year when they want to set the exams. And you know what? They also put up past year papers. It's put up online one. There's an online platform. Guess what? This staff put the wrong paper. He put the coming exam paper online. The one which is coming out.
Then how?
Wow, too late. Even though it was there only for a few hours, but they have to take it down, of course, and reset the whole paper. And there were only about 2-3 weeks left for the exam.
How does it accept?
But wow, you need people to set. It's not set by one person now. It's set by about 5 people.
The staff gun get.
They still have another group of people who check the paper. So you have to do everything all over again.
Was he fine?
He was in trouble. He didn't get promoted for the year.
I thought he would get like how?
No, not that serious, but it's serious enough. So that happened, then you better grab quickly download first.
It's not on news. Was it on news?
I think eventually they recycled it some years further.
Check your SP, I mean your poly.
Yeah.
Your poly.
Yeah.
Very good.
Most influence on the energy.
Oh, by the way, number 8, make sure you get it right at Jin. If not, better voice out. Thinking correct, number 8.
What? Yeah, same.
Will it be a problem?
Sure, just sit this question, I think. Let's see. T2H2N2H4. Oh my god, this thing. Someone draw it before. Who drew it before? Joe?
Okay, tell you what, guys, finish up on the MCQs and also finish up the homework.
Yes.
4 pages, you feel only.
Too much.
Too much. Okay, what MCQs only.
No, I mean the other one.
All right, any questions from the girls at home?
No.
Okay. All right. If you have, of course, you can still just message in the group chat. All right. If not, then yeah, we'll be all for today. Alright, so see you next week.
Bye
I try to
bye.
do this.
Because. Oh, this one, we have to know.
Are you not the right thing? Stop consider. Will it be tested? No, right?
Your teachers can be crazy enough, man.
What O-level tests?
Oh, yeah, of course. O level, of course, possible.
Were there recycled questions from the past?
Yeah, of course.
What do you mean?
Yeah. Okay, come guys. You have to draw dot cross diagram if you want to be safe. But remember these two especially.
All two.
It's not a single bond or double bond, and this one triple bond.
Nutrition.
Yeah, remember these two guys. N2 and O2, must remember. You can tell me if you forget, let's say this one you can forget it, that's fine, but these two, must really know.
It's like triple bond.
Why is nitrogen triple bond? You draw your dot cross again. But then, just like that.
What's it?
7. Because, they got 3 out, so got 4 even.
Yeah.
Okay.
No problem.
Now just, oh, I didn't do the last one. Oh, I did already. Okay. Okay,
Done. Okay.
I need to stay too long.
I've been spending like days on email.
If we know what?
I've been spending days on email, and I still cannot do some questions.
Oh, really like that?
I'm pissed. I feel like I just spent like just focus on email better. But then email gonna be hard this time also, so I was
Is it?
Yeah.
How do you know?
the Chelsea gonna be hard.
Oh,